So let's continue, like I said, on to the back here from our warm-up. All right, and take a look at these questions that we've got. All right, so again, taking the square root of a number is the, oops, sorry, I'm kind of zoom out here. Okay, and again, there's different ways to kind of fill this in. I don't think there's necessarily like one right way to do it, but here's what I kind of came up with, okay? Taking the square root of a number is the process, okay, of finding what number multiplied by itself that gives you the original number. Okay. So when you take the square root of something, it's the process of figuring out what number multiplied by itself will give you that original number. Okay.
Wait, what does that say? Gives you the what number?
Process of finding what number multiplied by itself that gives you the original number. No, that's okay. It's my sloppy handwriting too. Okay. Braden, we're on the back of the paper for the warm-up, okay? We just started. So, right, when we see this, for example, 5 squared, okay, what is 5 squared? 25, right? So, if we do the square root of 25, what is that going to equal? 5, exactly right, okay? So the square root kind of undoes that perfect square. 25, actually, let me do it this way. This might even make more sense here if I do it this way, okay? So then the square root of 25 is the same thing as saying the square root of 5 squared, and the square root and the square cancel, and we're left with just plain old 5 there. Okay? Same thing with 3 squared, that's 9, and so the square root of 9 then will be the square root of 3 squared, which is then just 3. 4 squared, that's 16, right? And the square root of 16 then is going to be the square root of 4 squared. And so what is the square root of 16? 4. Okay, just 4. Okay. Now, actually, I'll talk about that in a second here. Okay. So, parts of a radical, or as Ms. Slager said, a surd, right? A surd. Okay. An expression that contains a square root is a, so yeah, I guess I'll say radical here. You could say a surd as well, I think, though. Okay, and it can have 3 parts. Okay, A, well, we already know what this letter in front is, right? What do you call the number in the front of a term? It starts with a C. The coefficient. Okay, so it's A times this thing here. Okay, this B, okay, this is called the root, but it's also sometimes called the index. Okay, but I'm going to refer to it as the root. So it's a root / index is what I call the B there. And the C, the thing underneath the root symbol there, that's called the radicand. Radicand. Okay, radicand. Okay. So it's kind of interesting here. You may not know this, okay, but we kind of use the word radical and root interchangeably, right? We talk about square roots, but it's also like a radical symbol, okay, and stuff like that we're using. Why do we call it a root symbol? Well, because in Latin, and is anyone in here taking Latin?
No, I'm not.
No one's taking Latin in here? Okay. So I'm pretty sure it's Latin, okay? In Latin, there's a word radix, R-A-D-I-X, okay? Now, radix sounds pretty close to what English word? Radish, yes. And where are radishes found? In the ground, right? Okay, like roots are, right? So radix is actually the Latin word for root. Okay, so you call something, when you call that vegetable a radish, right? Well, it got its name because it's like a root vegetable. It's grown in the ground. Now, I don't know why carrots aren't also called radixes or anything like that, or potatoes too, stuff like that. Radishes, though, it's from the word radix. It's because it's a root. And that's why we also call these things roots, because root and radix, it's the same thing. Okay, just two different languages. That's all. Okay? So, back to what we're talking about here. So, we'll go ahead and simplify some of these radicals right here. Okay, so what's the square root of 100? 10. Square root of 25? 5. Square root of 144? 12. Square root of 16? 4. Square root of 121? 11. Square root of 64? 8. Square root of 9? 3. Square root of 81? 9. Easy. And these are easy because these were all perfect squares, right? But what if we don't have a perfect square? Well, we'll see about that in just a second here. Okay.
You had that little thing in your calculator.
You do have the square root in your calculator. That's true. You can use that. So I'm going to give you guys another paper here we're going to look at. Okay, and get a little more practice with simplifying square roots that are not perfect squares. Okay. I'll give you some and I'll take some maybe. Do that. Okay. Pass down these. Say again? What do you mean for that one? Is radical. All right. So here is how we're going to review simplifying square roots, because again, it's a review. We've seen this before last semester in 1A, but I know it's been a while, you know, in some cases maybe it was before winter break. I forget if we did it after winter break or not. Do you remember, Mr. Stever, if we did this before winter break or after winter break? Okay, I think that's probably true. Yeah. Okay, so when it comes to simplifying square roots, all right, we're going to use this very important property right here, the product property of radicals. And why do you think we call it a product property? Well, because we have a times b there. When you take the square root of a product, so we're taking the square root of a times b, you can break that square root up over the product. So in other words, instead of root a times b, I can do root a times root b, okay, as long as a and b are both positive. Okay. This is also true for division. So you could also say just as easily, if you see the square root of a over b like this, okay, that's also equal to the square root of a over the square root of b like this. Okay, and that would be the quotient property then of radicals. I guess I should kind of keep this separate. Okay, quotient property. I can zoom in on that some too. There you go. Okay. Now, what two operations are missing from this list, though? Adding and subtracting. So in other words, if you see the square root of a plus b like this, okay, that does not equal, in general, the square root of a plus the square root of b. There may be exceptions, but in general, you can't break up a square root over addition or subtraction. Okay, but you can for multiplication, you can for division, but not addition or subtraction. Okay? All right. Let's see how we're going to use this then. So, what is the square root of 4 times the square root of 9? Well, what's root 4 equal to? What's root 4? 2. What's root 9? 3. So 2 times 3. And so what's that going to equal? Equals 6, right? Okay. What's the square root of 36? 6. Okay. How are these two problems related?
Well, they both equal 6.
They both equal 6. That's right. So that means they must equal each other. So in other words, the square root of 36 is equal to the square root of 4 times 9, right? Like 36 is 4 times 9. Which means then we can break this up and say it's equal to root 4 times root 9. And there's our 2 times 3, and there's 6. Okay, so there we use that product property of radicals. Right? When you multiply inside, you can break it up. Like that. so it turns out that's always true, right? And here in this case, right, if you have the square root, we can go backwards too. So here, where I had a product inside the square root and I broke it up, okay, here if we have a broken up product, they're both underneath the square roots, I can put them together under one square root. So root A times root B gives me root AB. Okay. Okay. So let's take a look at some examples here. Okay. The square root of 25 times the square root of 4 can be written as, okay, so right, we can make it 5 times 2, because what's the square root of 25? Just 5, and the square root of 4 is just 2. So we could write it like this, or we could multiply those two numbers together and get the square root of 100, right? 25 times 4 and get root 100. But what does 5 times 2 equal, and what does the square root of 100 equal? Both are equal to 10. Okay? Let's try root 16 and root 9. Okay? What's the square root of 16? 4. What's the square root of 9? 3. Or we could say 16 times 9, which is 144. Okay? What's 4 times 3, or what's the square root of 144 equal to? 12. Okay? What about this one? What's the square root of 49 times the square root of 5? What's the square root of 49? 7. What's the square root of 5? Jackson? Sorry. Yawn attack there. Square root of 5, you said 1? Is 1 squared? What's 1 squared? 1. So square root of 5 can't be 1, because square root of 1 is 1. Square root of 5 is not 1. So what is the square root of 5? Is 5 a perfect square? No. And so we're going to leave it the way it is, because it doesn't simplify. Alternatively here, we could write root 49 times root 5, right? What's 49 times 5? Well, if you multiply that out, you're going to get the square root of 245 when you multiply it out there, I think. Do these two have the same value? Is 7 times the square root of 5 the same thing as the square root of 245? What's that? No? We all agree? No? Or we're not sure, maybe? How can we figure it out? Divide by 5? Well, we could try dividing by 5 here. What tool do we have available to us to help us determine if these two things are equal? Yes, Guy? Yeah, how can we use our graphing calculators to determine if these two things are equal? What can we do? What can we do here? How can we use these to help us figure out if they're equal or not? Olivia? Okay, so in our calculator, 7 times, now the square root button, if you don't remember where it was, it's second and then x squared. Second x squared. If I scoot it up here, you can see it a little bit better. You can see the square root symbol right there in blue for me. So second x squared. And then 5. So just like this, Olivia, you said? Okay. And then, Olivia, what should I do now? I typed it in. Should I just hit enter? Okay, so there's that. Now, how can I use this information to determine if that's the same as the square root of 245? Like this? And hit enter? And what are we looking for here?
It's the same thing.
It's the same thing. So, do these have the same value? Yes. Yes, they're the same. The decimals are the same, right? So this is not a bad strategy that Olivia just mentioned here. Sometimes, right, we just need to know if they're equal to each other. So, for example, if it's multiple choice, if you just type in your answer and then you check all the multiple choice answers, you just match up the decimals and you know you found the right answer, okay? So that's a way you can kind of use your graphing calculator as to your advantage there. All right, turn the page. So let's talk about simplifying radicals then. Okay, zoom out a little bit there. Okay, simplest radical form, right? So in other words, we couldn't simplify this so that we couldn't simplify this all the way so the square root disappeared, right? The earlier ones, we were able to make the square root disappear and get just nice whole numbers here. But here, our final answer had to have a square root in it still. So that's what we're looking for here. Simplest radical form, okay, is a radical is in simplest form if the radicand, the thing underneath the square root, has no perfect square factors, okay? So we're going to reverse the process, okay, and write the radicand as a product of two numbers. And then if one or both of these numbers is a perfect square, then the radical can be simplified. Okay? So these are our perfect squares. Okay, remember that's just 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, all the way up to 15 squared in this case. Okay, so there's 14 squared, there's 13 squared, so on and so forth. You get it. Get the idea. Okay. And so we're going to look at 900, and we're going to ask ourselves, okay, are there any perfect squares that divide 900? Well, first of all, let me ask this. Is 900 a perfect square? Well, we can check our calculator and type in square root 900. Oh my gosh, it is a perfect square. It's 30. 30 squared. Okay, so our final answer here is 30.
So the first one would be 10 times 3.
So, right. Let's do it step by step, though, here. So it's not 10 times 3, Grayson, because 10 times 3 would be 300. We need 9. So 10 times 9. And not 10 times 9. 10 times 9 would be 90. We want 100. There you go. 100 times 9. Okay. Now, we also could have broken this up into 3 times 300, right? Or 2 times 450. Why do we want to use 109 here? What's special about 109? They are both what? Perfect squares, right? We're trying to simplify this. So this product inside the square root here, we can now break up root 100 times root 9. What is the square root of 100? Anybody? Square root of 100. 10. And then what's the square root of 3? Or square root of 9, Erica? 3. And so then 10 times 3 gives you 30. Okay? All right, let's go to 12. Is 12 a perfect square? Let's check. Square root of 12. It's not, right? Yucky, yeah, nasty decimal there. Okay? So we need to see if we can simplify it. Are there any perfect squares that divide 12? 4. Yep, it's 4 times what?
3.
Yep, 4 and 3. Very good. So we'll break up 12 to be 4 times 3. Okay, which then will break up the square root and make it root 4 times root 3. Okay. Trey, what is the square root of 4?
2.
So it's 2. Yep, square root of 4 is just 2. And then we still have that square root of 3 underneath there. Okay, are there any other perfect squares that divide 3? No. So we're done. That's how we know we're done. It's just 2 times the square root of 3. That's our final answer there. Okay, let's try another one here. Root 48. Okay, is 48 a perfect square? Nah. All right, so now we have to think. Are there any perfect squares that divide 48?
7 and 6.
7 and 6 is 42. You're close. The 8 and 6 would be 48. But the problem if we use 8 and 6, though, Trey, is that 8 is not a perfect square and neither is 6. We want to use numbers that divide 48 that are perfect squares. So what can we do here?
Maybe 4 and 12.
4 and 12. Okay, that works. Very good, Eric. So we'll say root 4 times 12. Okay, and then we'll break that up. It's square root of 4 times the square root of 12. Okay. Let me finish this one here and then I'll let you go. Yeah. Okay, what's root 4? What's the square root of 4, anybody? 2. And then we have the square root of 12. Okay. Now you might be tempted to stop here, but are there any perfect squares that divide 12? What's a perfect square that divides 12?
4 and 3.
4 and 3. Yeah, we can break up 12 into 4 and 3. So we still have the 2. Root 12, we're going to make it root 4 times root 3. Okay. And what's the square root of 4? 2. So we already have the 2. We have another 2. And then we have the square root of 3. Too many numbers? Oh. Noted. Complaint noted. Oh, we're not done. Are we? What do we still have to do here? How can I further simplify this? Yeah, the 2's are both outside the square root there, and it's a product, so we'll just make it 4 square root of 3. Okay, are there any other perfect squares that divide 3 besides 1? Are there any other perfect squares that divide 3 besides 1? No. We're finished. All right, Erica. Thank you for your patience.
Thank you.
I know, I was keeping you in prison.
Yes.
Okay. Questions on that one? Question on square root of 48. Is this too easy? Do we remember it somewhat, hopefully?
It's fine. I don't think I've done anything like this.
Okay, well, we if you were in 1A last semester, we did. Okay.
Yeah.
Square root of 30. What are perfect squares that divide 30? Is 10 a perfect square? No. 2? 2 is not a perfect square. Any perfect squares that divide 30? 1, but that's not going to simplify it at all, so we can ignore the 1. 5 is not a perfect square? Nope.
Is it 10 and 3?
10 times 3, but 10, neither 10 nor 3, neither of those are perfect squares, so it won't simplify. Right? So like I hear, for example, I heard someone say 1, so that's 1 and then 30, but the square root of 1 is just 1, and we're back to the, well, 1 times root 30 is just root 30. If we use 10 and 3,
How about 15 and 15?
hang on. If we use 10 and 3, neither of those are perfect squares, so again, we're kind of stuck. Because you can't simplify the square roots. Okay, 15 and 15, careful, that's 15 plus 15 that equals root 30. We have to multiply. So you can do 15 and 2, but again, is 2 a perfect square? Is 15 a perfect square? No.
Did you try 6 and 5?
6 and 5, are either of those perfect squares?
Can it be a no solution or no?
So right. So what do we say here then? The answer is square root of 30. That's as, it doesn't simplify. You have to leave it, okay? We've exhausted all of our perfect squares. None of them divide 30 evenly, and so we're done. Okay? Now, did I have to check any perfect squares? Did I have to check all these perfect squares? No. Which ones could I ignore? If I'm just trying to simplify root 30, which ones can I ignore here?
Like 16.
Ones with 0 at the end.
Anything above 30, right? Anything above 30. Okay? There's actually, you can even restrict the list even more. I'm not going to tell you how to do that just now, but if you want to look it up or something like that, you're welcome to. All right, let's look at number 5. Now, number 5, it's partially simplified already, isn't it? 2 square root of 32. So we're going to leave that 2, but can we break up that 32 with a perfect square at all? What perfect square? Yeah, Frank? Ah, very good. Frank said root 16 and root 2. Was anyone going to say root 4 and root 8? 4 and 8? You could do it that way too if you wanted to. Okay. But this is the best way to go, Frank. So excellent choice. Okay. What is the square root of 16 there, Frank? 4. And we still have the root 2. And then to finish simplifying here, what goes together? Anybody? 2 and the 4, which makes 8, right? It's 2 times 4, so 8 square roots of 2. Okay, and again, of course, 2 can't be simplified. Let me finish this last one here, and then we'll let you go. Okay. All right. 1/5. Can we divide 150 by any perfect squares? So, Scott? 25. Root 150 is root 25 times what? Ooh, yeah. If we break this up into 25 and, yeah, it's going to be 25 and 6. 25 times 6 gets us back to that root 150. What's the square root of 25? 5. Okay, and we're left with the square root of 6. What's 1/5 times 5? 1. So you do 1 root 6 or just root 6 is fine. Okay. Now, what we are doing here, right, is simplifying radical expressions. These are expressions, not equations, right? Mr. Whitmire, I see an equal sign. Doesn't that make it an equation? No. It's an equation if we have variables, right, and we are solving, like we have a left-hand and a right-hand side that we're solving. The equal sign here is more kind of like showing our simplification steps. I mean, yes, these steps are all equal. We're not really solving for like a variable or anything like that, okay? Later in this week, we will be solving equations that have square roots or use square roots and stuff like that, okay? In those, we're going to end up with 2 solutions for our problems. But for these right here, okay, there's just one solution because we're just simplifying, okay? And we'll talk more about that later when we see the 2 solutions versus the 1 solution. So I want you to go ahead and try A, B, C, and D here, okay? Go ahead and give those a try. A, B, C, D. Take like a minute. Oh, yeah, sorry. Okay, take like a minute or 2 and try A, B, C, and D. Simplify them as much as you can. Next question. Yes. Yes. Okay, so go ahead and try A, B, C, and D. Okay, if you already got them done, I'll come around and take a look at them here in just a sec. So that's good, but now's your pencil. It's still this. Okay, and then what is the square root of 25? What's the square root of 25? And then you still have the square root of 2. Are there any other perfect squares to divide 2? What's the square root of 2? Nope. So you're done. Okay, put that in. Let's check your work here real quick. Don't forget there was a negative in front, so it should be negative. Yeah. What happened to your pencil?
It was
Destroyed. You'll have to go sharpen this one now. Y'all do enough math here? So this is true, but you see the problem you run into is that it can't simplify it all. So when you think of two other numbers that multiply to 18, try and use some of these little squares to help you figure out if it does work or not. Okay? Use some squares. Yes, eventually. What? Where'd your paper go? Oh, Eric was helping get some help. All right, this is pretty good. Pretty good. Now, one thing I'm going to point out here, there was a negative in front of the 300. Right? You see that in front? So that negative should still be in front here. But if you do a square root of 100, it'll be negative 10 root 3. Okay. Make an bend over. That's just cruel. I will. And then, you understand this stuff okay then? Alright, yes. That's right. Yeah, good job. Why did you think you didn't do it right? What about it? That was right. Good job. Alright, now letter B. Think about the perfect square root of 550. But you said this was 3, right? So that 8 is still the reason why the perfect square. That is still. Yeah, so this is good. Now what is the square root of 9? 3. So you would write 3 root 2 then. So you're like that, okay? And then here, good job here. Yes, so this 2 is still underneath the square root as well. There's 2 times 25 equals each. And so then what's the square root of 25? You're not sure. Second, x squared. So, what's the square root of 25? 5. And you still have the square root of 2. Can you divide 2 by any more perfect squares? No. I never collected them, I guess, did I? On Friday. You're right, I forgot. I'll get them tomorrow because it's just going to be too much, I think. Give you a few more minutes here, folks. Give you a few more minutes. 1 or 2 more minutes here. A few folks still trying to finish up, so I'm going to pass out this second page here. Actually, you know what? No, I'm just going to go over this first, and then I'll pass out the second page here. Okay, so let's take a look at our answers. Okay, there's A, B, C, and D. Okay. Now, any questions on A? I want to talk about C for sure, but we can ask about A first. Any questions on A? Okay, 18 was 9 and 2, so it becomes 3 root 2. Okay, B was root 50, right, which is 25 and 2, and the root 25 becomes 5. I want to talk about C real quick, okay? So one thing you do have to watch out is that there are different ways to break up 72, okay? For example, I saw that 72 was 36 times 2, but some of you saw that root 72 was what times what? What was some of y'all's first step? 8 and 9, right? Some people did this. Is this wrong? No, it's not. Does 9 times 8 equal 72? Yes. Is 9 a perfect square? Yes. So this is okay. I did it differently, but you can still do it this way. What you get, what's the square root of 9? 3, square root of 8. Here's where our methods, my way differs from your way. When I did mine, okay, I was left with the square root of 2. There were no more perfect squares that divides 2. But are there perfect squares that divide 8 still? Yes. What perfect square divides 8? 4. So we have 3 root 4 root 2, right? 8 is root 4 times root 2. And the square root of 4 is 2. So we get 3 times 2 times root 2. And 3 times 2, of course, makes 6. And we get the same answer we got before. Okay? So, it's helpful if you try to find the biggest square root. It's helpful if you try to find the biggest square root. All right? One way you can do that is if you go to your list up here. So let's just say hypothetically 72 is what we're looking at here. If you go to your list up here, okay, here's 72. 72 would be between 64 and 81, right? 72 would be between here. So what you can do is you can actually guess from the highest square root down, okay? Some of us are maybe checking the lower square roots and moving up, but if you check the highest square root and move down, you'll hit 36, and you'll see that it works, right? So just as a tip, a strategy there, 72, what we're trying to take the square root of, fits between 64 and 81. Look at the square roots below that. So try 64, then 49, then 36, so on and so forth, until you find one that works. And that'll give you the biggest square root, and it'll simplify it the fastest for you, okay? Negative 300, okay, that's negative root 100 times root 3, so it's negative 10 times root 3. Okay, I think most people did the 100 there because it was easy enough to see. All right, questions on A, B, C, or D there? Okay. Your homework for tonight, okay, I've got all these problems right here.
Oh, no.
All right, I would like you to do the
5 of them.
evens. You know what, not even that much. Let's just do like the multiples of 3. So 3, 6, 9, 12, 15. Okay, so you can just do these, these right here. Just 5 problems for your homework, okay? 3, 6, 9, 12, 15. I'll pass these out. 1, 2, 3, 4. Pass it down, please. 1. So again, 4. Stop. Yes. Can you make sure Sierra gets one of the
I'm already stressed.
You gotta make me, your mom's gonna be disappointed.
Oh, trust me, there's certain girls on that team I'm ready to just like whack.
Sorry, Scott. There you go. So 3, 6, 9, 10, 12. Oh, nope, not the ones in the back. Just this side where it says CC Algebra 1 at the top. 5 to 6. Common core. Okay. You might want to circle the ones you're supposed to do.
I just did multiple of 3.
Just these right here. Okay. Just those. Okay. Multiples of 3. 3, 6, 9, 12, 15.
That's a lie.